Aj.
Yes, sir. Morning, morning, morning. Good evening, good evening, good evening.
Yeah. How was
Uh,
it? Yeah, it's your morning, right? Don't you have
yes,
work today? I
it's my
mean,
morning. Yeah, I have work. I just finished a meeting, but you see, this our stuff is getting closer. I'm supposed to start the project next week Tuesday, so this coming
ah,
Tuesday. So I want us to cover as many as we can. That's why
yeah.
every
Okay, okay. Sure.
opportunity I want us to do stuffs.
Okay. Sure. Let's do.
Yeah.
Okay. I
Okay.
have shared my screen.
Yeah.
Let me get my event sheet. It's my browser. It's here. You can see the browser, right? Okay. Let me
Yeah.
try. HTTP. It's this one. Okay. Admin EU HTML5. Okay. Here I have my setup. So let me start the Palo Alto because let me see. Oh, yeah, I can start it because I need
Mhm.
another VM, but it can be connected to the switch. Okay.
Okay.
Till Palo is getting loaded. So let me get a Jay, give me one moment.
Sure.
5 minutes, Jay.
That's fine. That's fine.
Macam. Keep on. Session ni awal. Ada macam mang padding kan macam ni padding juga. Hari. Okay, Jay. So, you there, right?
Yeah, I'm here.
Okay. Okay. So then let me add a new VM that is Linux. Okay. Let's rename as PC. PC. Okay. Save. And let me keep it here. Save. Okay. Let me see whether the Palo started or not.
So what we are dealing with is the U-Turn NAT.
Yeah, we're starting with U-Turn NAT. So same zone and two zone, and then we are going for intermittent routing.
Okay,
So
so from PC to www using the public IP address, or what do you call it?
yeah,
Right?
yeah. Let me do this. Let me get my open board.
Mhm.
Open board. Mm, so- okay. What happens is when this is the PC. Let me get another color. When this PC, let's say this is the company web server,
Yeah,
and when this PC is trying to access the web server, so it is getting resolved to the public IP or the untrust IP, this IP getting
yeah,
resolved to this IP. So the PC has to go this way,
yeah.
and it has to take a U-turn in order to access the web server. So this is the traffic scenario here. So that's why it is called U-turn NAT. So let me see
And the
whether.
reason is why, because it doesn't have direct connection with the web server, the PC.
No, Jay. No, that is not the reason, because actually
Okay,
this the PC has a direct connection to the web server, because
exactly.
actually those are in the same switch, same
Okay.
switch.
So
But the
why do
problem,
we want to do the U-Turn NAT?
yeah, the reason is, let me explain that. The reason is, let's say, because actually this is a common scenario within organizations. What happens is, so let's say they have this web server, and let's say they have their website for, let's say, www dot let's say abc.com. And so they have published this FQDN within a DNS server, because we need to have mapping, right? So let's say here this IP is I'll put the okay. Let me put a sample IP, but we don't have a public IP here, right? Let's say 200.1.20. Let's say 5, and within this DNS server, let's say this is Google DNS, and this mapping is cached there. So let's say this is www.abc.com, and the mapping is this FPDN maps to 200.1.20.5. The thing is, Jay, so people from outside world, so let's say there's a PC, someone on the internet, and when they are using this, let's say they are using Google DNS or some other DNS. So when they are trying to access www.abc.com, so actually their request comes to this Palo Alto firewall and trust interface.
Yes.
From the Palo Alto, actually we do DNAT, and we are sending this traffic to this web server.
Yes.
Normal scenario. But the problem is actually when this PC, let's say most of the organizations use their DNS servers, public DNS servers, and let's say this is 888. And when this PC, let's say this user wants to access their own website, their company website, for let's say for some updating purposes. So when they're trying to type this www.abc.com, they are going to resolve this name to the same IP, 200.1.20.5, instead of this direct IP. That's a problem. So
I
then
know. So can't that website have two interfaces? One for the public, which is the NATed IP, and the other one for the internal users.
No, actually that is not required. So we have another option. So we can have only one, because actually this web server has only one IP, and it's a private IP. This IP is actually the firewall IP. But the thing is, actually, if something like that should be happen, so what they can do is, if they're using an internal DNS server, so then we can do it. Let's say they have internal DNS server, they can put the mapping. They can put the mapping www.abc.com is whatever the private IP. So then when this user is trying to access that site, so they can resort to the private IP. They can access the web server directly, no problem.
So in that case, what you are saying, you said they can do the mapping. So it's called mapping, right?
Yeah, mapping. It's a generic word, actually. This is a record, actually. When it comes to, let me show you that. Let me get my command prompt and show you. Actually, I think you know this, right? NS lookup. This is very important tool for any network administrator.
Of course, I do.
Yeah. You know that, right? So let's say I have a website called set5 A, and then let's say www. Let's say this one, live.net. Actually, these are the area codes. Actually, these area codes are within the DNS server. So actually, the mapping means a generic word, but actually, technical word is actually we are putting a record, actually host record. So here within the internal DNS server, we can put a host record. Internal DNS server, we can put a host record pointing to the private IP of the web server. That is possible. But let's say in certain organizations that they use the public DNS servers within their PCs. So in that case, actually, this is a problem. So in that case, actually, we have to use the U-Turn NAT in order to access the website. So that is the requirement here.
Okay. Yeah, I understand perfectly. I just wanted that explanation. Okay, thank you. Okay. So if we have to access it privately, we have to do a DNS mapping so that it can be pointing to the, that means we have to create a record. within the private DNS,
Internal
so
DNS.
that
Yeah.
yes,
Private DNS we
that
have to
way
do
it
it.
can be pointing to the private IP. That means that web server will have both public and private IP address.
Yeah, actually, public IP is actually it belongs to the firewall.
To the public, yeah, to the
We are not
firewall.
assigning,
Yes,
firewall.
yes.
So what we do is we are just putting a destination NAT within the firewall, and we are
Oh, that's
accessing
true.
the.
That's
Yeah.
true. So that web server has only private IP.
Yeah, actual web server has
Yes,
private
private
IP.
IP.
So
Okay,
that's what
okay,
normally happens.
okay. But
So
the people from outside are able to access it just because of the destination NAT, because they are only connecting with the firewall public IP, and the firewall knows where they are going when they make any requests.
yeah.
Okay.
But actually, Jay, we have another when I'm doing BGP, but I'll give you a basic
Okay.
idea. So, in certain cases, actually, we are having public IPs assigned to servers directly. So, I can
Okay.
give you one example. So, what happens is, I'll give you a basic idea, but when I'm doing BGP, I'll explain it more.
Yeah.
The thing
I
is,
need that BGP.
yeah, the thing is, let's say you have a, let's say this is your firewall, and this is your firewall, let's say PA, and let's say you have a very critical web server. Let's say you are a bank, and this is your online banking system. This is your online banking. So online banking means, so then this is a critical one, right? Because it should be available anytime, because people do all the transaction here. Online banking. So in that case, actually, let's say you have one internet connection here, and if this internet connection is going to be down, so then no one can access the online banking. So it's a big issue. So in that case, actually, we have something called multi-homing. Multi-homing means what we do is we have two internet connections, and we have two ISPs. Let's say there's a ISP one connected here and the second ISP connected here. So what this organization should purchase a AS number, autonomous system number, AS number.
Yes.
When it comes to AS number, so that means you are going to have a public IP block. It owns by this organization. So this organization should advertise that. Actually, let's say, for example, let's say they are going to get this public IP range. Let's say 40.1.1.0, let's say /28. 28. So 28 means that they are going to have 14 IPs.
Yeah.
14 IPs. Usable, 14 usable, otherwise 16. So then they have to advertise this range. So then only from people from the internet, let's say this is the internet, people from the internet can access this web online banking application. So let's say this application has 40.1.1.5. So what happens is, in this case, we are having the public IP assigned to this online banking. So what we do is we have a BGP peering. We have BGP peering with both the ISPs, and we are advertising this 40.1.1.1.0 range to both these ISPs. We are advertising.
Why are we having two ISP?
Because let's say this ISP is going to be
Okay.
crash.
Okay.
So then
Okay.
this advertisement is going to be stopped here.
And
So
they
then
don't.
the
Yeah.
people from the internet is going to use this path to access
Okay.
online.
Okay.
But let's say this ISP goes down, but both ISPs goes down, nothing to do. But let's say this
Yeah, that's rare. At the same
then
time, that's going to be rare.
going to be stopped, and the people from the internet is going to use this path. So
Yeah.
actually, that's called multi-home. So in that case, actually, we are assigning these IPs
Yeah.
directly.
I think your microphone is messing up now.
One moment.
Okay.
Let me see. Can't you hear me?
Yes.
Hello?
I can hear
You
you.
can hear me. Completely. So in that case, I think we are not assigning the public IP. But other than that, actually, we are assigning private IP. But public
Oh, I can't hear you anymore. It's going far, 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 far away. Are you using your microphone today?
Can you hear me now?
It's far away a little bit. It's not like before.
Okay. Now can you hear me?
Yes, I can hear you anyways.
Okay, you can hear me, right?
Yes, it's better now.
Okay. So,
Mhm.
so that is the scenario. So, okay, let me.
Okay, so because of multiple service provider, that's why they're advertising a range of IP addresses, right? The 40
Sorry.
dots, 40. I said because of the two service provider, because they are utilizing two service provider, that's why
Mhm.
they are advertising ranges of IP instead of one single IP, public IP.
Yeah, actually, the reason is, Jay, actually we own this because normally when it comes to normal scenario, let's say this scenario.
Mm.
One moment. This scenario. What happens is this IP range is actually not advertised by the ISP. Actually, this range 200.1.1.2.5. If this AS number is not owned by us, so then this IP is not going to be advertised by our router or firewall. Actually, it is
Okay.
advertised by this service provider, because let's say this is our service provider. They are advertising it to the internet, this 200 range. So we are just assigning this IP into the firewall. So even though this, let's say this link is going to be down, even though this link is going to be down, this advertisement is still there on the ISP. ISP is still advertising it. So anyway, the people are coming through this ISP because
Yeah.
advertisement is there, because
Yeah.
we are not advertising this. But
Yeah.
in this case, since this AS number, autonomous system number, is owned by us, owned by this bank, actually
Mhm.
this bank is advertising this 40 range. So
Okay.
if this link is going to be crashed, this link to the ISP is going to be crashed.
Yeah.
So then this advertisement is going to be stopped. This, let's say this advertisement is going to be stopped. Actually, in this case, we cannot control this advertisement, because
Yeah.
actually this is advertised by the ISP. Even though this connection between ISP and us are going to be down, the advertisement is still there. Because of that, all the people from the internet are
Okay.
try to access our online banking system through this ISP.
Okay.
But here the scenario is different, because actually
Mm-hmm.
we are advertising this IP range. We are
Yeah.
advertising this IP range. So because of
Okay.
that, if some one of the links, because we are advertising through two links,
Yeah.
we are advertising through ISP1 link and ISP2 link.
Yeah.
If the ISP1 link, because the thing is, actually when we are advertising these these IP ranges, we are using something called, I'll explain it when I'm doing BGP attributes. So
Mm-hmm.
we can steer, we can decide through which ISP these people should come to access
Okay.
the online bank.
That's like a little bit of what's it called? Load balancing.
Yeah, actually it's not load balancing, but actually we have another option. Since you're talking about load balancing, I'll tell you that option. I'm just giving you the basic idea, then you can think about it. That
Okay.
option is, Jay, what happens is, actually what we are doing is, we have let's say this a firewall, and
Uh-huh.
here let's say your online banking is this, let's say on,
Mhm.
and you have a load balancer here.
Okay.
You have load balance and you have two links from two
Yeah.
ISPs. But here we
Yes.
don't we do not have any AS number.
Yes.
And what happens is, this load balancer act as the authoritative DNS server. So that means the primary DNS server for this domain, this online banking domain. So when someone wants to access this online banking system, when they type, let's say, www.abcbank.com,
Mhm.
so this is the authoritative DNS server. All the DNS requests are coming to this load balancer. Load
Mhm.
balancer can advertise either this link or this link. So then
Mhm.
load balancer is going to check the mostly,
The
I mean,
status.
the best link, and he is going
Mhm.
to advertise that IP. And let's
Mhm.
say if this link is going to be down, so then
Mhm.
this load balancer is not going to advertise this anymore. It's going to
Mhm.
advertise only this link. So that is another option.
Okay.
Yeah, actually, when we are doing BGP, we'll do these
Okay.
things.
No, I
Yeah, we have.
understand. I'm understanding it very well now.
Yeah,
Both
because we
options
have
now.
many
I'm
options.
understanding
Yeah,
it.
we
Yeah.
have many options. But
Okay.
the thing is, most reliable option is this one. But the thing is, actually, this is pretty much costly because I also a few years ago I also wanted to purchase a AS number because only for fun. Actually, I don't have any requirement. Purchase this AS number to advertise through my I have a server rack and I have Cisco stuff there, so I wanted to advertise my own network range to the internet, but unfortunately the thing is you have to pay lots of money
Yeah.
for this AS number. It's a
Yeah.
monthly payment. So because of that I didn't do it.
Yeah.
So that is the good thing. Okay, let me remove these things.
Okay. Good. 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 Good.
Actually, Palo Alto supports BGP OSPF.
Yeah.
So those were supported there. So okay. Okay, let me log into the Palo Alto here. Okay. Hmm. Okay. So both have the /2 is the untrusted and /1 is the trusted. So this is the IP 172.1.254 is the IP that we are going to use to access the website. That is the
What?
IP for the
Ah,
U-Turn.
your voice. Okay. Like it
Okay.
has come back. Your
Initially,
voice was gone.
can you hear me now?
Yeah.
Okay. Okay. So initially, what I can do is let me log into the website and see whether the website is up and running. Hmm. Let me go to terminal and see whether the website is running. Sudo, actually these commands also important sometimes if you have to manage something like Linux, so this is important. Sudo system ctl status apache 2. So this is the command to check whether the service is running. Yeah, the web server service is running active. Okay, so then let me log into my PC. But anyway, I think I had to. Uh, Actually, here let me see the IP range. This is 10.0.0
Mhm.
IP range for the trust zone 10.0.0/24. So then we have to have web server. See the web server IP. Can you hear me?
Yes.
Okay. Okay. Let me see the web server IP. Web server IP is 10.0.0.1. And let me try to assign IP address for the PC. Okay, so let me log in here. Test 3. And let me add the IP address, let's say 10.0.0.50 for the PC. So service 10.0.0.1. And the firewall trust interface is 10.0.0.254. Okay, so here wire connection and wire settings, wire connection, wire connection. Okay, here let me set the IP range here. IPv4 manual. And I'm putting, let's say 10.0.0.50, and the network mask should be 24, and the gateway is 10.0.0.254. And let me put the DNS. Let's say 8.8.8. Apply. Okay, it's connected. So I can check whether I can, whether I can access the web server directly.
Mhm.
So let me see. So actually that is a possible scenario where we have an internal DNS server. So then
Mhm.
we can publish that host record or the record by mapping the private IP. Maybe let me check first. I think I started the switch right away. Oh, this was
Okay.
so it's 10.0.0.1, and I should be able to get the web server page. Okay, we can access the web server directly, right? But my requirement is actually I should be able to access the web server using 172.16.1.254 IP. That is my firewall public IP or the Antras IP. This point. Okay, so then let me try with that IP. Uh, 172.16.1.254. So we know that actually we cannot access because actually we don't have anything configured. So this is not possible, right? So what I'm going to do is now I'm going to do the what you call same zone U-Turn NAT. Actually, as you know that now I'm glad that you know that actually we don't need a security rule
Yeah.
since it's an interzone, because actually
Yeah.
since this interzone rule is allowed, action is allowed, we don't need. But in case of we are denying it for certain different deployments, actually we have to have a rule. But here we don't. 99% actually we don't need a rule.
Yeah.
Okay. Now I'm going to put a rule here. We have one requirement. When it comes to this NAT rule, J, we have the order is important. I'll tell you why order is important. Let's say I'm going to let's say U-Turn NAT. No, give me one moment. Before that, let me help now. Okay, U-Turn NAT. Um, okay, and original packet. Actually, this traffic initiated from trust zone, right?
Yeah.
And this traffic is going to the untrust zone because actually we are trying to access the untrust interface. So
Yeah.
here this is untrust. Okay. And the source range, let's say our source range is 10.0.00/24. And the destination is 172.16.1.254. That
That's
is
the,
our
the
firewall untrust IP.
okay.
Okay, that's logical, right?
The source address is the PC address, right?
Yeah, actually here, since let's say we have several PCs, so because of
Yeah.
that, actually
Yeah.
just
I
put this
got you.
up. And this is the important part. Actually here, I'm going to keep this source address translation for a moment because actually we need it. But for the moment, I'm not going to do it because I'm going to do step by step. I'm going to do static IP and
Translation
I'm
type
putting
static.
10.0.0.50 because we need it. Our destination should be translated into 10.0.0.50. So that is my not 50, I guess it's one, right? Web service one. Web service one, I guess. Let me see the IP. I think it's one. Okay, yeah, it's one. The web server IP is 10.0.0.1. Okay, this should be one because actually we need our destination address to be translated to 10.0.0.1. Okay. Now
So
we are fine, right?
that's the web server IP, right?
Yeah, web server IP. This is
Okay.
we are accessing from trust to untrust,
Yeah.
and this is the source address range, and this is the firewall untrust interface. Then 172.16.1.254. If
Yeah.
our original packet match this, so then we are going to translate it to this IP 10.0.0.1.
Yeah.
But we need to have a configuration here, but for the moment I'm not going to do it. Let me
Okay.
click OK. Okay. So okay, I'll do this. Okay, let me do. Okay, because we have two things here. Let me close this.
What's that?
That is my one moment. How do you- Okay. So let me commit
Mhm.
because we have two issues here. I'm going to
Okay.
tell you that after trying the web server using the firewall public IP or the untrust IP. So after trying that, I'll tell you the two issues, because actually we have to be logical, and when we are doing this way, actually it's kind of a troubleshooting, because when it
Mhm.
comes to network, if you are going to deploy something from the scratch, I think that is pretty much easy. But if you
Mhm.
need to troubleshoot which has already been deployed, so it is somewhat difficult, because actually we have to think about many aspects. So that's why I'm doing this way. Actually, you are pretty much good, Jay, because you think about these, you actually try to think logical. It's pretty much good, because sometimes I do
Yeah.
sections, but they do not think about. They just try to memorize things and do. It's not a way to learn
Yeah.
anything.
Yeah.
Yes, because actually the thing is, when it comes to networking, let's say you are doing systems. Let's say you do Linux, but actually it is not logical. But when you are doing
Mm.
networking, it's logical. Actually, there is a theory behind it. When it
Yeah.
comes to math, I know that. I mean, let's say DNS server, it's logical. And for DNS, it's
Yeah.
logical. But I'm saying, I mean, the implementation of these things are not logical. Let's say you have error with certain file. Actually, you have to Google it, and you have to find it. But when it comes to
Eh,
networking, it's pretty much logical. So
It's
interesting.
logical, yes.
Yeah. Okay. Now what I'm going to do is, let me check the time here. And time is it's 8:41 within this
Mhm.
firewall, because I need to track this traffic.
Okay.
Okay, let me try to access the web server from here, from the PC. That is okay. It is just 1, 2, 3. Okay, this is the one I'm trying to. Okay, now let me go to. Let me
To
see here. See,
monitor.
it's not loading, right? It's not loading. Just try to connect. Let me go to firewall
Mhm.
and see, this is the traffic I guess. See, destination is no, not that one.
Source.
No, this one. It's right. We are trying to access 170 something. Uh, 0, 0.
Yeah, it's right
Yeah,
there.
yeah, this one, right? Okay.
Mm-hmm.
No, not that one. Right? This is destination is this,
Source.
but our destination should be 170.
Huh?
This is not the one. The destination should be 170. Let me see. This destination is 888. We don't see traffic.
The IP of the PC is what?
Okay, so here, actually, here the thing is, actually we are accessing 172.16.1.254. This is the
Yeah.
IP we are accessing. So from the firewall logs, we'll see whether we can see such a log here. Try to filter it. Destination 172.16.1.254. Okay. Now this is all the logs. This is not. This
A
is some.
whole log.
No,
Yeah,
no, this is
but the
not.
log we are seeing is is accessing 888, and the NAT is okay.
Okay, let me go
Before
to
bef Yeah,
policy
okay.
and
Because you remember we are trying to access 172. That's an untrust zone.
yeah,
So
and so.
I need a policy for this traffic.
Yeah, we need a policy, but actually, I'm trying to see whether this is going to be denied or something like that
Yeah,
from the
we're
file.
supposed to see the log as at least.
Yeah. Yeah, that's the thing. So let me go to security policy and see whether we have logging enable. I think both logging enable like this. This is inter zone default actions. Log at session in. Okay, let's wait some time to see whether we can see this. Okay, we can see. See.
Huh?
No. This
Okay.
is the old one. Old one. This is
Oh
not the
yeah.
one. This is something some other configuration. I think. Mm, let's see. Actually, let me see whether my PC has access. So the firewall. Let me see whether this is fine. Wired connector, wired setting. This is for okay, it's 10.0.50 and this is fine. And my interface is 10.0.254. That is all. Yeah, so okay, that is fine. One, seven, 16. First and go. Okay, let me go to monitor. Hmm. Okay. It's a good thing, Jay. Actually, this is
Mhm.
pretty much important. I'll show you one thing. So the reason, actually, it's a by it's a good thing for you to understand this. So you
Mhm.
can't see any logs, right? So let me do this thing. Let me go to packet capture.
Mhm.
Let me go to packet capture and let me manage filters, because when it comes to Palo Alto, you can do packet captures from the
Mhm.
monitor and from the packet capture option. And
Yeah.
let me go to manage filters, and I'm going to filter certain traffic and see to get a packet capture. And ingress interface is actually I'm using, I think it's my trust interface is, I think, this one, Ethernet 1/1. And my source IP range is 10.0.0. Let's say I'm putting the actual IP. That is my actual IP is 10.0.0.50. And my destination is 172.16.1.254.
Mhm.
Okay, so that's enough. So let me click OK. Now I have a, because you have to remember when you are enabling packet captures within a production firewall, J, it's important to put a filter, because otherwise, if you are not going to put a filter, everything is going to be captured here and your
Of
firewall has
course.
a performance degradation because of
Of
these
course.
happening.
Because a lot of
Yeah, a lot of traffic is going to be captured
traffic.
by the firewall.
Mhm.
Yeah, and then I'm going to start the packet capture. Okay, one moment. Before starting the packet capture, I had to add the stages here.
Mhm.
Here, actually, I can see these stages. Drop means actually when traffic is getting dropped. Firewall means actual firewall is actually doing firewall. Firewall means that in policies, NAT rules and all. And receive means actually it's receiving something, and transmit is transmitting something. Once received, actually firewall is going to forward it to someone, right? Actually, this traffic is not for the firewall, right? Firewall is forwarding.
Mhm.
But here, for the moment, I'm just going to see the drop count or the drop traffic. I just want to capture the drop traffic here, and let me start the packet capture.
What if it's not going to drop?
Sorry.
What if the
If
traffic is not going to drop?
Yeah, if nothing is going to be dropped, we don't see anything here because if it's something is dropping, we can see a file here. So that means all the captured drop traffic is going to be saved in the file. From here, we can see that. So let me try this, try again, and let me refresh. See, we can see drop traffic here. Let me open that. I'll tell you the reason. So that's why we can see that.
For this manual filter, right, that we put in place,
Yeah,
we put manual filter, which is fine. We have the source destination. Now,
yes.
if we want to configure the stage, can we not configure multiple? Like can we not configure drop, configure fire?
You can. Yeah, you can.
So that
You can
whichever
put
one
all the stages. Yeah.
that, okay.
Yeah. But for the moment, because actually I identified the reason
Okay.
that why we
That's
can't
why
see
you
any
know
issues. Yeah.
specifically.
Yeah.
Okay.
Because of that, I just wanted to show you that because of the reason I
Okay.
only did it. Give me one moment, Jay. I think my Wireshark is on there because other laptop. Let me get it. Uh, Okay, so open this. Before, I mean, till my Wireshark is downloading, so till it's get downloaded, let me tell you the reason. This traffic is actually getting dropped. The reason is what happens is, uh, this PC, this PC is trying to access, the firewall and trust interface, right? This location. This location, this IP is 172.16.1.254. But let me go to file and show you. When it comes to this firewall, let me go to policies, NAT policies. Here I have an internet NAT policy. That means when traffic is going trust to untrust, I ask firewall, please NAT this traffic to this IP 172.16.1.254. Jay, give me 1 minute.
Okay.
Hello, Mach. මොකද මචං? නෑ හරි හරි. අනේ මචං මේ මං ඔබට හරියටම 10 මාට්ට ගන්නද මම පොඩි සෙෂන් එකක බං ඉන්නේ මං ඔබට ගන්නම් ඈ මට මතක් වුණා ඔබ දාල් මං හිතුවා ඔබට අවම වෙන්නේ නැති කියලා මං ඔබට ගන්න අනිවාර්යයෙන් මං ගන්නම් ඔබට 10 මාර්කෙට ගන්නම් හරි yeah Jay, you there?
Yeah, I'm
Okay.
here.
Yeah, okay. So here you saw that we have a existing NAT policy because this NAT policy is a generic internet NAT policy, right? When traffic is initiated from the trust zone to untrust zone, I'm asking firewall, okay, please do the source NAT using this IP. So that means this traffic, this IP packet, source IP is going to be changed to 172.16.1.254. So the problem is I'm going to access this IP 172.16.1.254. What happens is my IP packet source IP and the destination IP both are same. That's why firewall is dropping the traffic because I'm accessing 172.16.1.254. This traffic. This means my IP packets destination IP is 172.16.1.254. But because of this NAT policy, my traffic source IP also 172.16.1.2. This IP packet has the same IP for the source and destination.
Yeah.
Because of
This is
that, firewall is dropping the traffic. If the firewall is
yeah.
dropping traffic, you can't see it in the
That's the
log.
source NAT, right?
Yeah, because of the source NAT,
Mm.
it's going to
Yeah.
be changed to this IP, but destination
Yeah.
also the same IP.
And because the source NAT is on top.
Yeah, on the top,
Yeah.
this happens. And also I'm trying to
Yeah.
access this IP. So in that case, actually, that's why I told you the U-turn
Yeah.
NAT policy position is important.
Okay.
And also you have to remember when file is
When
dropping some
this
traffic, you can't see that traffic within the traffic log.
Mhm.
And let me my voice shark is
But
downloaded, so let me
we
open
cannot see it on in the log.
the monitor. We can't see that because of this traffic is getting dropped. It is not going to be printed on the log, so we
Hmm.
can see. See, still we don't see such a traffic here.
Hmm.
So that is important
So
because
if something like that is happening, then
you have
you want to filter those traffic
you
to
can't
based
filter
on the policy to see how many, policies they have in place. Maybe whether there is any conflict in policies, just like now.
yeah, so the best thing is, Jay, actually you can do a packet capture and see whether there's a traffic captured within the firewall. So otherwise
Okay.
you can see that within the traffic log.
Yeah.
Yeah, that is important. Now let me install my watch. I can show you that the source IP and the destination IP. Okay, till it is getting installed, let me make this correct, so then we can see the correct
Yeah.
configuration. Let me go to NAT and okay, let me do this thing. Let me
You move it to the top, right?
yes. Okay, I'm going to move. Oh, okay, now let me commit it. Now
So
one issue and
let's say you have up to 200 policies
okay,
ahead of that, on top of that U-turn NAT. And
yeah,
you only
yeah,
want to move this U-turn NAT to a position of 50, not top.
yeah,
How do
yeah.
you
You
do
don't you
that?
don't you don't put it in the top. Only thing is this U-turn should be before the normal source name.
Exactly.
Yeah, you don't have to put it into the top, but
Yeah,
then
I
you
said
have to place
for
it
you.
before this NAT.
Yeah,
Because
for
the
you
thing
to
is, when it comes to firewall policies, even both security policies and NAT policies are evaluate top to bottom.
so
And
what
if
I'm
one,
saying,
yeah,
yeah, what I'm saying, if let's say we just want to move it to the top of the internet and we
uh-huh.
still want to have other rules ahead of it, how do you do that?
Okay,
Because
okay, you
if you
you
move
can
it
you
to the
can
top, it's going to go
no,
all the way to the top, right?
you can drag and drop actually. You have many options. One
Yeah,
option is
you can
committing
drag
NAT.
and drop. Yes,
Yeah, but
exactly.
you can do it, but it is pretty much risky because I can share one of my experiences. So actually, actually I had some medicine because of certain disease. So then that day I was at one of my clients because when I was working for a company and I
Yeah.
was configuring policies and I was sleepy and by mistake I drag and drop one policy into some other location by mistake because of my
Oh
busyness.
yeah.
So then one of the services got stopped working, their
You
production
know.
network. So then I had
Yeah.
to, in such a scenario, the best option is you can go to commit here. So
Mhm.
since we do not have anything, I'll tell you later. I'll tell you after some time. You have very important option there. So in order to move policies, what you can do is you have many options. Let's say if you want to move this, you can go to move and you can move up. Move up means one step up. But let's say if you want to move in certain customized location, you can drag and drop actually. See,
Mhm.
you can do this. Let's say you're going to put it here.
Yeah.
Right. See,
Yeah. Yeah.
but it is somewhat risky, Jay, okay? Sometimes you may drag and drop some other policy. So it is risky, but do it with yeah.
Yeah.
Okay, now U-turn NAT is before the normal source NAT. So now what I can do is, let me go and try to access the web server from the PC. Oh, okay. Let's let's
Yeah. Yeah.
yeah. Now it's wait, okay. Okay, now let me go here, firewall, and let me go to monitor. And now let's see whether we have any. See, we have now. See,
Hmm?
this is a traffic. Now the date
Mm-hmm.
is today, and now time is fine. Now we can
Mm.
see this traffic is
Source
fast to
50.
fast. The
Yeah.
source is 0050 and
Not
NAT source.
IP.
This is source. We don't need this one. Destination is 172.16.1.254. See,
Yeah.
let me go back here. Still, we don't. It is not working. Here you can see this, it says application is incomplete. Actually, application is incomplete because actually the total traffic is not going through the firewall. So let me open this magnifying glass to see the details. You let me go here. Byte send. See, byte send is 74, but byte receive is 0.
Yeah.
Byte receive. The reason is, let me go here and tell you.
Mm-hmm.
The reason is what happens is when we are accessing this location, the firewall is going to do the destination NAT. So from the logs, actually, we can confirm that. Let me go here and let me see the destination. See, destination NAT is done here. Firewall is reading the destination NAT. But the problem is when traffic is destination NAT, it is going to reach the web server.
Mm-hmm.
But web server sees this traffic is initiated using this PC's IP because
Mm-hmm.
actually this PCs try to access this web server. So the web server is going to send the return traffic directly.
Hmm.
Not with,
Okay.
it is not going back to the firewall. That's a problem. That's why we can't see the return byte received. So because of that, actually what we have to do is we have to go to this policy and we have to do source net as well within the same net rule. We are
Huh?
doing destination and source both in one net rule.
So what do you have to do now?
Okay, let me show you that. We are going to translate the packet and we are doing the source net as well.
Okay. Okay.
Because we are going to change the source IP into the firewall trust IP. So then the return traffic is going back to the going back to the firewall. Then the firewall is going to forward it back to the PC.
Wait.
So we are doing the source
Source
net.
address translation. Okay.
Yeah.
So
So
this
what
IP
happened?
is what IP? 254
254. Let
is
me show
the
you.
source is the IP
This
of
is
the
our
PC.
this trust interface IP, the firewall trust
Okay.
interface. So let me
Okay.
tell you here. What happens is when we are doing the source NAT, the PC is accessing the firewall and trust interface,
Mm-hmm.
and firewall is doing destination NAT. While doing destination NAT, it's going to doing the source NAT as well. So it's going to do the change the destination IP to the web server IP and going to change the source IP to its trust interface IP. So then the web server sees, okay, this traffic is initiated from the firewall. So then
Mm-hmm.
the web server is going to send the return traffic back to the firewall
Mm-hmm.
without directly sending traffic to the PC.
Yeah, I
Because
get you now.
this web server doesn't see that this has been initiated from the PC because of
Mm-hmm.
the source NAT. So then the web server
Okay.
is going to send the return traffic back to the firewall. Then the firewall is going to send the return traffic back to the PC.
Yeah.
So that's why we need the source NAT here. So let me go back to the
Yeah.
firewall. I think I did the commit, right?
No,
Let's see.
you didn't commit.
I committed, right? Okay. Now let me go back to the PC and file.
You have not committed it yet.
I didn't commit it. Okay, let me commit. Okay. Let me commit it.
Let me grab water.
Okay, sure.
Yeah, I'm back.
Okay. Okay. Uh, See now the website is working because the previous problem was even though we did the source net, I mean destination net properly without source net, what happens is when this when the PC sends the traffic to this interface and it's going to be destination NAT to the web server, but since we didn't have that source NAT, the web service send the return traffic directly to the PC, but PC doesn't have any idea who's this person is, because actually PC didn't initiate any connection to the web server IP, right? PC
Yeah,
initiated connection to this IP.
yeah.
So because of that, this scenario is not working. This is going to this place, and this firewall is going to do the destination net, and the
Mhm,
web server is going to serve the web page directly to the
mhm.
PC. PC is thinking, okay, this is uninvited response from
Exactly.
some other server, so I don't want to accept it. Just drop it.
Mm.
So so what happened? The working scenario is PC is accessing this IP, and
Yeah.
we are doing the source and destination net both, and
Mhm,
traffic is coming to the web server. Web server is going to respond back to the firewall,
mhm.
and then the firewall is going to send this traffic back to the PC using 172.1.254 as the source IP. So then PC
Right.
knows, okay, I requested the website from that IP, and that IP is sending me the response.
Mhm.
So actually, that is the same zone U-Turn NAT. Actually, here we do not need any what you call security policy because of
Security
interzone.
policy.
Interzone.
Yeah.
Actually, it
Yeah.
matches to the interzone. So,
That's right.
okay, so that's it, Jay. So then let's move into the two
Okay.
zone U-Turn NAT. Give
Okay.
me 1 minute. Jay, give me
Yeah.
1 minute. Let me get some water and come.
Yeah. Me too.
Okay, so I'm here.
Back.
Um, so, okay. You can hear me, right?
Yeah.
Okay, so now what we can do is, so let me clean this and
Yeah.
here we are going to stop this PC.
Mhm.
Uh, no, not the PC. PC, we can keep it here. So let me stop the, sorry, and the PC. Alright. Okay. Okay, so I'm going to stop the web server and I'm going to keep it in some other zone within the firewall. So then so then anyway, I have to shut down the firewall as well because I had to
Mhm.
connect this and I had to stop the switch as well because I cannot remove it otherwise. Uh, Let me delete the connection. Okay, and let me keep it here.
Mhm. Create another interface for the
Yeah,
firewall.
yeah, firewall. It's let's say Ethernet 1/3.
Mhm.
Okay, now actually this is called different two zone because
Mhm.
actually my PC is within the trust zone and my web server is within some other, let's say DMZ zone.
Mhm. Mhm.
So here also we need to have a U-Turn NAT
Mhm.
because here the scenario is, let me draw it here. What happens is when this the PC has, let's say this PC has public DNS server configured 8.8.8.8, the same scenario. So then when this PC wants to access this company website, their own website, so this PC is going to resolve this IP, the IP here. So then
Mhm.
the traffic from the PC is going to reach the firewall Suntrust IP,
Mhm.
and it should be come back to this zone, different zone,
Mhm.
using the destination NAT. So, but
Mhm.
here, but we need a security policy because these are
Yeah.
two zones. No,
Yeah.
yeah, two
Two
different
different
zones.
zones.
Two
Yeah.
different zones. Okay, we'll wait some time. I think it takes some time to get this ported. Um, yeah. Sorry. Right. Right. Okay, till that, let's say, let's have some different range IP. Let's say we have a 172 range for the ultras and 10 range for trust. So we'll have 192 range here
Mhm.
because we have 192 range behind the router, but since it is not, we are not using it, we can use.
Mhm.
Okay, let me close this. This is okay. Typing. Just want to do. Otherwise, no, let's say 1002 range because otherwise sometimes the setup may we may require that whole setup for some other practicals. Okay, we have 1000. We will have 1002 range for the DMC. And we go to wire settings. Settings. Before I'm going to just change this socket here. Sorry, let's say 1002, 1002, 10021,
You're
and
changing the
this should be
subnet.
yeah, changing the subnet 10.0.2.2.5.4. So that is a firewall interface. I had to configure it within the firewall.
Mhm.
Let me apply and let me close this and save it. This up. Okay, it's up. Okay, and then close. and for network interfaces, and I'm going to configure this as the DMC interface, Ethernet 1/3. So this should be layer 3 interface, and virtual router is the same. And the security zone is going to be, actually I have DMC interface configured, I think for some the practical. Okay, DMC and the IP range, let's say 10.0.2.254/24. This is my DMC interface. Okay, so then let me go to OK, and then okay, so um, okay, here let me directly configure it. So is the PC? Is the PC? Yeah, this is the PC, right?
Mhm.
Test 1, 2, 3. So what I'm going to do is uh, I'm going to access the firewall address interface, and it should destination NAT the traffic into the web server. So that should be happen here. So let me go here and initially let me do the NAT role. Okay, so here actually in this case it is not a problem. I mean when it comes to this, I'll tell you that one moment. Let's say two zone U-turn NAT. Let's say two zone U-turn NAT. Okay, and our original packet is from the trust zone,
Mhm.
and it is going to untrust zone.
Mhm.
It is going to trust. It is starting from trust zone to untrust zone,
Mhm.
and source range is 10.0.0.0/24, and my destination address is 172.16.1.254. Okay, okay, that's it. And then translated packet. Here, actually, we don't need source translation, Jay, because the thing is actually
Yeah, the
because
policy will take care of it.
yeah, no, not because no, we need a policy, that's right, but the reason is not that. So let me tell you.
Okay, I got you. I understand. Because there is no direct connection from
Yeah,
PC to
yeah,
that.
yeah, because when the PC, I mean,
Yeah.
when the PC is trying to access this,
Yeah.
this firewall public IP. So it's going to be destination attached to the web server, and the web
Mm.
server sees, web server sees the source address as the PC's address, but actually there's no direct connection. Anyway, this web server should send return traffic back to the firewall, because the firewall is the default gateway for
Yeah.
the web server. So because of that, we don't need this thing. Give me one moment. So, um, one moment.
Mhm.
Okay. Okay, so then I can go here, and here let me do the snack. So that is we are having 10.0.2.1 like this. 10.0.2.1. Let me see
That's
whether it's
the IP
web
of
server.
the
Web server. We are doing the registration act to the web server, right? So let me
okay.
see whether it's. So I think it's 2.1 like this. IPA. Oh, it's 2.1. Uh, Let me see why it's setting. and settings.
Translated
Let me
IP.
go. Yeah, 2.1, but I think I have to reset the connection. Let me.
Wait, if you go to that, go to the diagram.
Okay, I'll go back. Give me 1 minute. Yeah, it's now 2.1. Okay, so let me go back here.
So that is the translated IP, translated destination NAT, right? No, sorry. The firewall itself, the place where you were, go inside the NAT, what we're configuring. Then we'll come back here.
Okay,
Go
so
go to the PA. The PA.
yeah,
Yeah.
what happens is
Okay.
here
So no.
I'm from the trust interface, trust zone,
Yeah.
and I'm going to the untrust zone.
Trust zone, yes.
Okay, so then this is the source range 10.0.0 to
Source
24.
source
Source is
the
source means the
PC.
PC range,
Yeah.
this PC.
Okay. Yes.
And then destination is 172.16 1.254. That is my
Yes.
firewall
The
untrust
on
interface.
trust, yes.
And translated packet, I'm going to
Destination
destination
address
NAT to
translation.
10.0.21. 10.0.21 means this web server.
Okay.
Okay, so that's it.
Okay.
And then, okay, so then let me click OK. That's untrust. Okay. Okay.
Hmm.
Okay, so here but I think we have conflict. Okay, we are going trust to trust, this untrust. Okay, 17. This is going to be the session is this. No, this is U-turn NAT. Sorry, this is a U-turn NAT.
Mm-hmm.
This is not okay. We have to keep it here. Let me put it in the top,
Mm-hmm.
and we are accessing trust to untrust, and source is this, and destination is this, and destination is actual translation is destination translation is 10.0.21.
Mm-hmm.
Okay, here I'm going to commit without putting a security policy. After checking, we'll put a security policy.
Mm-hmm.
Yeah, sometimes you see there's a conflict. So because this U-turn, two zone U-turn at single zone U-turn at there's a conflict. But the thing is actually anyway we have to have two different public IPs within the firewall, because otherwise we cannot access the same two web servers using the same IP, because we are using same port, right? So because of that, actually this is not possible. So in that case, actually we need to if we need two web servers, uh, even though it's anything anyway, we need to have a separate IP. So because of that, this is not won't be a problem, because we are not going to use same IP for two web
Sorry,
servers.
I stepped away.
Sorry,
What was the issue? I stepped away. What was the issue?
do you want me
I
to explain
stepped
that?
away. Yeah, I stepped away. I mean, we committed already, right?
Yeah, we committed.
Mm-hmm.
Okay, let me show you now. Let me go to PC, and it's not. Okay, now let me get a new window. 172.16.1.254. Oops. What happened?
It's working?
Okay, let me go to firewall and see whether I have a what policy here. This is the problem. Actually, I have any policy here. Trust to untrust. No, this won't work. This should be trust to no, this should not work, because actually this is let me check it again. Should not work. Now let me copy this and let me go to private window and paste go. Oh no, it's not working. It's previously cache. See, it's still loading. So actually I can show you from the log. Let me go to firewall monitor and this should be to DMC. See, traffic is dropping. The traffic from Trust. 2 zone is the post NAT zone. Jay, give me 1 minute. Hello?
Okay, I hear you.
Hello?
Yeah, I
Oh,
can hear you.
that one conversation again.
Huh? No, I can hear you.
Yeah, Jay, you can hear me, right?
Yeah.
Okay, okay. So here, Jay, see, it's getting denied. So let me put the highlight policy action. See, it is denying. So we need to have a security policy. So let me put the security policy here.
Okay.
Let's say 2 zone U-Turn NAT. NAT, okay, NAT security policy. The source zone is the trust and source address range is handle 0.0./24. And here the important destination zone is when it comes to destination NAT, you can just remember that. Otherwise, I'll explain you after some time. There's another reason for this. This is the post NAT zone. Post NAT zone means DMZ.
What
The
do you call it?
destination is
Post.
post NAT zone. After netting,
Okay, post
the
NAT.
zone is DMZ, right? Because you are doing a destination NAT. The post NAT zone is after you are doing the destination NAT, the zone is DMZ because you are netting to the web server which is placed in the DMZ. So when you are doing the destination NAT, that is post NAT zone. When you are doing destination NAT within the Palo Alto, you just remember this for the moment. After some time, I'll explain it the more logical reason. Because
Okay.
at this moment, if I'm going to explain it, somewhat difficult for me to explain. Because I have to do certain few things other than this. This is post NAT zone and destination address should be pre-NAT IP, not post NAT, pre-NAT. 172.16.1.254. This, sorry. Because your post NAT IP is 10.0.2.1. That is the web server IP, right? But your post NAT IP is the firewall and trust IP, 172.16.1.254. This is post NAT IP. Before netting. This is post NAT zone. Sorry, pre-NAT IP. Pre-NAT IP. Pre-NAT IP. Post NAT zone.
Pre-NAT.
It's like a song. Right here. You just remember it for the moment. You can tell when destination NAT. Let me write it here.
Okay.
When
we can finish this in 25 minutes, right?
Yeah, sure.
Okay.
When DNAT.
I have a meeting. When
in security
NAT.
pre-NAT IP post-NAT zone.
Oh, yeah.
Just write it down because it's easy. In the when DNAT pre-NAT IP post-NAT zone. Just remember that because when it comes to normal destination NAT also the same. But after some time I'll explain more logical reason for this. But just for the moment.
Okay.
Okay.
So the address the IP address we are going to use is the untrust interface of our firewall.
Yeah, that is the pre-NAT IP.
But the zone is going to be the DMZ. We are not going to use untrust.
After netting.
Okay.
So I'm going to keep the application any for the moment. Let me click OK. And I can show you that this is a generic destination NAT, right? The thing that we did last day. So here also the same.
Oh, yeah.
Destination. This is the this is the post NAT zone because this is destination NAT. Someone is accessing your web server from the internet, right? So he's coming from untrust zone, and this is a post NAT zone. This is a pre-NAT IP. The untrust interface IP. Pre-NAT IP, post NAT zone. Just remember that. Okay, let me copy. Let me comment it. And now we should be able to access pre-NAT IP, post-NAT. Pre-NAT IP, post-NAT.
Hmm.
Because from the log, actually, you can see that from the logs. From the log, actually, when it comes to destination NAT, from the log, you see the pre-NAT IP and the post-NAT zone.
Mm-hmm.
Yeah, I'll show you that once it's done. Once we access the web server using this NAT. Okay. Okay, now let me go to PC and let me try access. See the web service. We can access the web server. So let me go to policy and show you from the policy we can see that traffic, the pre-NAT IP postnet. So this is the traffic. See, this is the postnet zone. Two zone. Destination zone is postnet zone, and destination is pre-NAT IP. Yeah. Just remember that. Let me refresh and show you the accepted one. This is the one. Now this is
So it's allowed.
allowed. This is allowed.
Mm-hmm.
And okay, that's it. So that is a two-zone U-turn NAT. Okay, actually we have more time. So do you have any question regarding this? So now I'm going for the VLAN.
Yeah, I have to. I'll watch it and make sure I get everything solid. But I understand it very well now. So
Okay, okay.
yeah, the
Okay,
VLAN
I'll
is
ask you.
gonna. Yeah, we have time, right? It won't take more than 20 minutes or 25.
Yeah, we have 25 minutes. Yes.
Okay.
Okay, let me go here. And actually, what I had to do is let me initially draw the diagram here. So what I'm going to do is actually this is pretty much important when it comes to firewall deployments because
Yeah.
thing is, Jay, you know,
Some
let's say
interfaces.
this is the Palo Alto.
Mm-hmm.
Actually, we have many two options. One option is let's say you have enough interfaces. Let's say you need to have DMCs on here. So you are going to connect a switch, layer 2 switch here to this interface, this firewall interface, and you are going to have many devices connected to this DMC zone. So this is a one zone. Let's say this is DMC.
Mm-hmm. James A.
Okay, so here let's say your untrust, that is your internet connection.
Mm-hmm.
And let's say you have another zone. Let's say you have a server, let's say internal server farm. So you have another interface, and you are going to have a layer to switch and connect it here, and you have your internal server. Let's say this is a server zone, something like server zone.
Mm-hmm.
And let's say you have another, let's say your PCs, let's say PC zone.
It's
You
like a
are connecting
trust.
a switch here. Let's say trust. Okay, you are going to have trust zone. And let's say you have another network. Let's say this is HR. I'm just giving an example.
Mm-hmm.
Let's say you have your physical interface and you are connecting a switch, and this is your HR zone. So actually this is possible, but the problem is this is not scalable. Let's say
Yeah.
firewall is going to have only 5 interfaces. You are going to have 100. Let's say 20. You need to have 20 zones.
Mm-hmm.
So in that case, you need to have a firewall with 20 interfaces, 20 more than 20 because you have to have your interconnections and all. So
Mm-hmm.
it is not scalable actually. So that's a problem. So in that case, actually we can use what you call VLAN interfaces.
Mm-hmm.
We can have VLAN interfaces. We not VLAN interfaces. We need to have VLAN. I'll tell you how to do that. Okay, so then what we can do is, let's say we have the function here, and here we are going to have our class interface as usual. And the thing is, actually, we are going to have only one interface here. just a one interface. But going forward, I'll tell you, but today I'm not going to do that since we don't have enough time. But normally, the best practice is actually we can have actually not one, we can have bundle. We can have many interfaces up to 8. We can have what you call ether channel.
Huh?
We can have a ether channel. It's a bundle. We can have many
What
interfaces,
what do you
and
call
we
it?
can
Ita channel?
ether channel. Ether channel. Ether channel means it's aggregated. In Palo Alto terms, it's called aggregated.
Yeah,
Aggregated
aggregate
ether.
interface.
In Palo Alto terms, this is the one. Okay. Today I'm not going to do that. Next week
Mm-hmm.
I'll do. Next week, next session I'll try to do it. Aggregate.
Yeah, your voice is cutting.
Can you
Yeah.
hear me?
Yeah, I can hear you.
Okay. Aggregate. Okay. But today I'm not going to do that.
Oh, yeah.
So in that case, what happens is let me see. Let me draw it again here. This is your firewall, and you have one trust interface. You have one trust interface. So here you have a Cisco. Okay, I don't have enough space. Let me do this. Let me draw it here because I need to explain it for doing. Okay, here what happens is here you have a Palo Alto firewall, and your organization wants to have 20 different zones. Actually, not zones. Actually, you are getting the requirement to have 20 different subnets, and
Yeah.
your requirement is you need to have each subnet. I mean these subnets should not be able to contact each other unless otherwise you allowed it to do so. So that is a requirement.
Yeah.
That is the requirement. Jay, give me one moment.
Okay.
Hello.
Yeah, okay.
Hello.
Yeah, I can hear you.
Oh,
Yeah, that's fine.
Other?
Yeah, I'm here. I can hear you.
මේ අරුගොත් දෙන්න ආවද? හරි හරි. Okay, so your company is going to give you the requirements that you are going to have 20 subnets,
Subnets.
and you need to implement network architecture where these subnets should not be able to contact each other unless otherwise you allowed to do so.
Mm-hmm.
So that is the actual business requirement. So in that case, what we can do is one option is the previous option that I gave you. You can have several physical interfaces and you can place each and every subnet. But the problem is if your firewall does not have more than 20 interfaces, you can do it, right?
Mm-hmm.
And what we are going to do is, let's say this is SunTrust, and we are going to have one interface here. And we are going to connect a layer 2 switch here.
Mm-hmm.
And we are going to configure layer 3 sub interfaces. I'm just trying to depict this here. This is layer 3 sub interfaces. These interfaces are tagged, actually VLAN tagged. There's a VLAN tag here within these interfaces. I'll show you that.
Mm-hmm.
So what we are going to do is we are going to divide this switch into separate VLANs. Let's say you need to have, let's say for the moment, let's say you need to have 3 VLANs. You are going to create 3 VLANs within the switch.
Yeah.
Let's say this is VLAN 10. Let's say this is VLAN 20. And this is VLAN 30. So here you are going to have one interface for VLAN 10. I mean, just a logical interface, not a physical interface. You have one physical interface, and you can break that interface into 3 logical interfaces: 10, 20, and 30. And let's say there's a PC within this 10 range, and there's a PC within 20 range, there's a PC within 30 range. And default gateways of this 10 range would be this one. And default gateway of this 20 is this logical interface. And the default gateway for this 30, this PC, is this logical interface.
Mm-hmm.
So that is the basic idea. So let's say if this 10 range wants to contact some server within the 20 range, then this 10 range cannot access this 20 range directly, even though it is connected to the same switch. because this is a separate VLAN actually,
VLAN.
virtual LAN actually, not virtual network, virtual LAN. So
Mhm.
in that case, since your the 10 this logical interface is
Please,
the
can you
default.
give me 1 sec? Let me answer this call, please. 1
Sorry.
second. Hold on, 1 second.
Yeah,
Let me
sure,
answer this call.
Yeah, sure.
Hello. Hello. Who's this?
Jay, give me 1
Yeah.
minute.
Okay. All right.
Give me 1 minute.
Okay.
Hi, Jay.
Yeah.
Okay. Oh, I'm sorry.
Yeah, that's fine.
Okay. So here, so what happens is, let me get the right color here. So let's say this person within this 10 VLAN wants to contact. Let's say this is a PC and this is a server. If this person wants to contact the server in the VLAN 20, so this person should send this traffic to this VLAN interface, logical interface.
Yeah.
And then it is going to route within the firewall. It's going to route. You just remember this way. This is routing and going to this 20 interface.
Yeah.
It is routing actually.
Yeah.
Because all these interfaces belong to separate security zones within the
VLANs.
firewall. Yeah, security zones.
Security zones, yeah.
So then this traffic is going to be routed to VLAN 20 and going through this link and reach the server.
Yeah.
And this link is called trunk. This is a trunk actually, because trunk
Okay.
means actually this link can handle VLAN tagged packet, because in the packet we have a VLAN tag 10, 20, 30. So the important thing is when this inter-VLAN routing happen within the firewall, let's say this is a PC zone, and let's say this is a server zone, and you can put a security policy between PC zone and server zone, saying, okay, this let's say this PC IP, let's say for example, let's say 10.0.10.1, and let's say server is 10.0.20.1. You can put a policy saying, okay, this is allowed, this traffic is allowed.
Yeah.
But unless otherwise you specifically allow this kind of, by putting this kind of a security rule between PC zone and the server zone, no one can contact from the PC zone to server zone, because actually this traffic is going to be matched with the interzone default rule and going to be denied. So that is the actual inter-VLAN routing using the Palo Alto firewall.
Okay, there has to be both. I mean, two-way rule policy in place.
No. You don't. Actually, the thing is actually, Jay, what happens is when it comes to Palo Alto, you can remember, right? When we put the internet access rule, actually we didn't put the return rule, right? We just put
that's
internet.
because you remember
trust to untrust. Okay. Because return traffic, because these firewalls are actually, I mean, they are stateful firewalls.
They're stateful firewall.
Stateful, because they know this traffic has been passed through the firewall. I should allow the return traffic.
I wanted you to say, that's why I said it. I knew. Okay,
because actually when it comes to Cisco, we have to do in Cisco and Cisco, I mean all the routers. Normally what happens is we have to put the return, but anyway it is nowadays it is they are putting manually automatically. But when it comes to firewalls, it's not like that. Firewalls are stateful now, so they know this traffic has passed through the firewall. I should allow the return traffic.
Yeah.
So actually that is called inter-VLAN routing. So
for in the what's it called? The VLAN, we have VLAN 10, 20, and 30.
Yeah.
So we can have multiple PCs in VLAN 10. We can have multiple servers in VLAN 20, right?
Yeah. You can have, because when you are defining VLAN 10, 20, and 30, let's say VLAN 10, you can define what would be the network. So for example, let me write it here. So let's say you can define, okay, your VLAN 10 is you can define, okay, my VLAN 10 is, for example, let's say 192, for example, 168 and 1.0/24. You can define this. But as a best practice, what we do is we just try to relay this number, because it's easy. Let's say if you are having 192.168 range, but it is not a mandatory thing. There's no logic, but it's somewhat easy if you are doing so. Let's say if it's VLAN 10, what we do is normally it's a best practice actually 192.168 10.0. Because when we see this number, we know, okay, this is VLAN 10. It's easy.
Okay.
Right? So let's say VLAN 30, we are putting 192.168 30.0.
Since this is the private IP, so we can twist it whichever way we want it.
Yeah, actually you can use, let's say if you want to have more than this, you can have, let's say 172 range, and you can have 16 masks. That's not a problem. But the thing is, so that's the thing.
Yeah.
Okay, so Ajay, I think we have no enough time to do the configuration part, I guess.
Yeah.
It's almost 10:30, so we'll do with the next session.
We'll continue in your morning. Your morning is my night.
Yes, sure. Tomorrow morning, but I'll be available around 8:30. the
Okay.
same time tomorrow, but let's
Yeah,
try to.
that's fine. That's fine.
Okay, okay, Jay. Okay, okay,
Thank you, man. Yep.
okay. Take care. Bye. Good night.
Yep. Yes,
Ah,
sir.
yeah, morning, right?